Okay, so segment addition. This time we're going to use segment addition to find the actual length of a segment. So again, just like we did before, segment addition tells us that if we have a point like this, t, that's in between two other points, like s and u, that the distance from s to t plus the distance from t to u will be equal to the entire distance from s all the way to u. So the two parts add up to the whole. Pretty straightforward. Now, we use that to set up and solve equations. We're going to do pretty much the same thing here, except after we're done solving the equation, we're going to go back in and substitute into one of the expressions to get an actual length, which we actually did before to check our answers. Alright, so let's take a look here. We're supposed to find SU, which is represented by the expression x plus 19. So let's see. We have ST, 11, plus 2x plus 13. 2x plus 13 equals x plus 19. So combine like terms over here, 11 and 13 make 24 plus 2x equals x plus 19. See, I'm going to take an x away from each side. 24 plus x equals 19. Now I'm going to take 24 away from each side. X equals negative 5. And then we have SU is x plus 19, which is negative 5 plus 19, which is 14 altogether. Now, we could double check here. If this whole thing is 14, then up here, see 2x plus 13 should work out to be 3, because 11 plus 3 is 14. Let's see. It'd be negative 5, so 2 times negative 5 would be negative 10. Negative 10 plus positive 13 would be a positive 3. So it works out. All right, here we have that GH, which is 2x minus 4 plus 2x minus 1 equals 11. I've got 4x all together. Negative 4 and a negative 1 make a negative 5. All that adds up to 11. We've got, let's see, add 5 to both sides. 4x equals, oh, wait a minute. 4. 2x minus 1. Something is right. Alright, I had a brain fart there. Add 5 to both sides and we get 16. Divide by 4 on each side. X equals 4. We're trying to find HI. So HI is equal to 2x minus 1. Substitute a 4 in there. 8 minus 1. HI equals 7. Alright, so let's go through a few more, move a little faster. See, here we have x plus 13 plus x plus 19 equals 8. That's 2x. 13 and 19 make 32 equals 8. 2x equals negative 24. X equals negative 12. IJ is x plus 13. Negative 12 plus 13 is 1 equals IJ. Over here, we've got 2x minus 10 plus x plus 4 equals 12. I've got 3x minus 6 equals 12. 3x equals 6. X equals 2. We're trying to find QR. That's 2x minus 10. That's 2 times 2 minus 10 for, wait a minute. That doesn't sound right. Hold on, I made a mistake. Look at this. I'm going too fast and I made a mistake. I know I made a mistake because 4 minus 10 is negative 6. It doesn't make sense to have a negative length up here. Notice I should have added 6. I subtracted. So this should be 18. So this should be 6. So over here, that should be a 6. And 2 times 6 is 12. And 12 minus 10 is 2 equals QR. Okay, that makes a little more sense. Okay.
Sammy, stop saying stuff.
Alright, let's look at some more in here. I've got FG. So let's see. We've got x plus 19 plus 1 equals 2x plus 32. X plus 20. 2x plus 32. 20 equals x plus 32. Negative 12 equals x. I'm supposed to find FG. FG is 2x plus 32. 2x plus 32. 2 times negative 12 plus 32. Negative 24 plus 32 is 8 equals F. G.
How about...
Oh, 8 equals FH. Oops, not what I wanted to find. I wanted to find FG. Well, no big deal. If that's x plus 19, negative 12 plus 19 is 7 equals FG. Plus, notice 7 plus 1, 8 pans out. Alright, over here we've got 2x plus 4 plus 11 equals 7x. 2x plus 15 equals 7x. 15 equals 5x. 3 equals x. We're trying to find TS. That's 2x plus 4. 2 times 3 plus 4. 6 plus 4. 10 equals TS. Alright, let's take a look at some more here. Here we have 7 plus 2x plus 12 equals x plus 19. See, we've got 2x plus 19 equals x plus 19. Alright, we've got x plus 19 equals 19, and x equals 0. We're trying to find LM. 2x plus 12. 2 times 0 plus 12. 12 equals LM. Here we have x plus 1 equals 2, plus 2x minus 16 equals 15. 3x minus 15 equals 15. 3x equals 30. X equals 10. We're trying to find j, k. X plus 1. 10 plus 1. 11 equals j, k. Okay, over here we've got x plus 10 plus x plus 5 equals 9. So we've got 2x plus 15 equals 9.
Hey, we're gonna sit on the porch for a minute.
2x equals 2x equals let's see, where was I? No, negative 6. X equals negative 3. And then we're trying to find VU. That's x plus 10, negative 3 plus 10, which is 7 equals VU. Okay, here we have 3x minus 6 plus 11 is 11 plus 2x. So we've got, let's see, minus 6 plus 11 is 3x plus 5 equals 11 plus 2x. X plus 5 equals 11. X equals 16. Trying to find RT. That's 11 plus 2x. 11 plus 2 times 16. 11 plus 32. That is 43 equals RT. Okay, down here we've got 2x minus 9 plus 2x minus 7 equals 12. Not right now, but I'm in the middle of something. That gives us 4x minus 16 equals 12. That's 4x equals 28. X equals 7. So we're trying to find KL. 2x minus 7. 2 times 7 minus 7, which is 14 minus 7, which is 7 equals KL. Last one. Alright, we have 2x minus 12 plus x minus 1 equals 14. That gives us 3x minus 13 equals 14. 3x equals 27, and x equals 9. Trying to find mn. X minus 1, 9 minus 1, 8 equals mn. So again, when you're working with segment addition just says that if you cut a segment, there's a point here that cuts a segment into two pieces, that the lengths of the two pieces add up to the length of the whole. You set up an equation that basically says that algebraically, and then you solve the equation. In this case, the only thing that's different is we've had to go back and substitute our value for x into one of the expressions to find out what the actual length was. So the trick here is just to make sure that you're actually following the directions. Am I supposed to solve for x or find a particular length? Alright, good luck.